12.3, inscribed angles. And we know what inscribed means. It means drawn inside. And so these are angles drawn inside of a circle. And they are going to have relationships with the arcs that they intercept. So let's start with some vocabulary here. An angle whose vertex is on the circle. Now that's important. And sides are chords of the circle. And remember that chords are a line that intersects a circle in two places. Okay, this is an inscribed angle. So if we look over here, we have our vertex is on the circle, and then our sides of our angle are chords of that circle. Now, the arc that has endpoints on the sides of the inscribed angle and its other points are on the interior of the angle is an intercepted arc. So we look here as our intercepted arc, and we can see that here is where our inscribed angle intercepts the circle, and the arc between those 2 points is the intercepted arc. So this is the angle that we're talking about here. Now, our first theorem is called the inscribed angle theorem, and it says the measure of an inscribed angle is half of the measure of the intercepted arc. So the measure of angle B, measuring that angle, is 1/2 of the measure of arc AC. Now, if we remember back, we know that if we have a circle and we have a central angle, the measure of our arc equals the measure of our central angle. So make sure that you keep these two separate, okay? Central angles have their vertex on the center, and intercepted arcs have their vertex on the circle. And so intercepted arcs are 1/2, measures of intercepted arcs are 1/2, or the measure of the angle is 1/2 of the intercepted arc. So let's look and see what we have here. We have 3 cases. In one case, the center is on the side of the angle. In another case, the center is inside the angle. And in our third case here, the center is outside the angle. Now, this does not change the value of our angle measure. It's still 1/2 the intercepted arc. It's just 3 different cases. And because this is a theorem, we know that it is proven. And so we have the proof here. We know that circle O is inscribed with angle B. So we're looking at this angle right here. And we have a diameter BC. Now that's going to be important. If we look here, we know that this is a radius, and this is a radius, and this also, OC is also a radius. These are going to be congruent because that is an isosceles triangle. And what do we have over here? We have an exterior angle. And we know from previously the measure of an exterior angle is the sum of the measures of the 2 remote interior angles. Measure of angle B plus measure of angle A. Okay, so, And what else do we know about angle A? We know that angle A is congruent to angle B. So we have used our exterior angle theorem here, triangular exterior angle theorem, and we have used our isosceles triangle theorem. And then we know that angle A and angle B are the same angle, right? They're congruent. So we can simply substitute here, put in B for A, and arc AC, because we know arc AC is congruent here to our central angle, our exterior angle. So we can just put in arc AC, we substitute in arc AC, the measure of arc AC, for our central angle, and we divide both sides by 2, and we end up with the measure of our inscribed angle is 1/2 the measure of our arc. So that's just the proof of how this works. Okay, let's look at how do we use this. We want to know all sorts of unknown things. Well, I see some inscribed angles. I see many of them. Now be careful here. Segment QT is not a diameter because it does not pass through the center of the circle. So we want to find the values of A and B. I bet we can find a lot more than that. So let's look first here at arc A. I'll draw that in too dark. And I can see that it has endpoints here at P and T. And I am going to use my color to highlight the inscribed angle that is associated with that arc. Okay, so I know my inscribed angle is 60 degrees, and I know that that is half of the measure of the arc, so I can say that arc PT measures 120 degrees. Okay, then I'm going to take another color, and I'm looking for measure of angle B here, another inscribed angle. It has its endpoints on P and S, so it goes all the way around like that. I know that this piece of it is 120, and I know that the other piece of it is 30, so that gives me a total arc measure of 150 degrees all the way from P around to S. And then I am going to divide that by 2, and this is 75 degrees. And there are other things here we could find. We could find the measure of angle QRS if we wanted to. We don't have enough information for that, actually. Never mind. So go ahead and pause the video and do the next 3 problems. All right, the first problem was pretty easy. We want to know the measure of angle A, so I traced out my inscribed angle here, and I find its intercepted arc, and I notice that I have a diameter, and I know it's a diameter because it passes through the center. And so I know that's 180 degrees. Half of that is 90 degrees. That means angle A is a right angle. We're going to learn more about that later. All right, I need to find the angles of, or the measures of these 4 inscribed angles. So I did A, and A I had to add up to 190, divide by 2, get 95. B, I did the same thing, got 77. C, again, had to add those 2 arcs, divide by 2, got 85, and angle D, I got 103 degrees. Now, the next question asks us, what do we notice about the measures of the opposite angles in our quadrilateral? Well, if we look at our opposite angles, they both add up to 180. Now that really shouldn't be a huge surprise for us. We have seen that happen before, but it's going to be one of our useful pieces of information. All right, let's look at our next theorems. Here we have some corollaries, and you remember corollaries are extensions of theorems. They're special cases, and our inscribed angle theorem says that the measure of our inscribed angle, the measure of the inscribed angle equals 1/2 the measure of the intercepted arc. Right? So, what do we have here? The first corollary, says that if we have two inscribed angles that intercept the same arc, are congruent. Well, this should not be a huge surprise because we have this inscribed angle with endpoints here, and we have this inscribed angle, and it has the same endpoints. So whatever the measure of this arc is, both of our inscribed angles intercept the same arc. They are going to be congruent to each other. Now the second one, this is what we saw earlier. An angle that is inscribed in a semicircle is a right angle. Again, not a huge surprise. If we are intercepting a semicircle, our arc measures 180 degrees, half of that is 90. So that's just a nice little shortcut that if you can remember it and you see that you have a diameter, you know, hey, I've got a right angle, and we do like right angles. And this third one here, we also learned this up above. The opposite angles of a quadrilateral that's inscribed in a circle are supplementary. So angle A and angle C are supplementary, and angle B and angle D are supplementary. All right, I bet we are going to use those corollaries to do these problems. We want the measure of each numbered angle, so we want to find the measure of angle 1. Well, here is my inscribed angle. Hey, I see that it is connected to a diameter, so I immediately know that it is a right angle and measures 90 degrees. All right, the next problem says angle 2 and the 38-degree angle intercept the same arc. Well, we know what's going to happen already. They intercept the same arc. So I have angle 2, and it intercepts that arc, and I have my 38-degree inscribed angle, and both of them intercept this same arc. So I know that if this one measures 38 degrees, that angle 2 is going to measure 38 degrees as well, because if two inscribed angles intercept the same arc, then they are going to be congruent. All right. Go ahead and pause your video and do the next problem. Okay. In the diagram at the right, we want to find the number of our measured angles. We see a quadrilateral inscribed inside of a circle, so we know there's going to be some special stuff going on. Now, the first thing I'm going to do is label everything that I can. I see a diameter, so I know that these two arcs on the top are going to be 180, so I can label that one 120. And the same with the bottom two arcs. 180 minus 80 is 100 degrees. And I can start with angle 4, and I see that it intercepts those two arcs, so I added them together, divided by 2, and got 70 degrees. Now I could do the same thing for angle 2, add 120 and 100, and divide that by 2, and that would come out to be 50 plus 60 is 110 degrees. Or we have our corollary that says that opposite angles are supplementary. So I know that measure of angle 2 plus the measure of angle 4 is 180 degrees. Angle 4 measures 70 degrees, and I get angle 2 is 110. So either way that works. And then I move on to angle 1. I see that angle 1 intercepts a diameter. It's a semicircle here, and so I automatically know that it is a right angle. It measures 90 degrees. I could also add them up and get 180 and divide by 2, and it would still be 90. I know that angle 1 and angle 3 are opposite angles and are supplementary, so it measures 90 degrees. All right, so you can have multiple ways of figuring that out, but if you remember your corollaries, there are shortcuts. Okay, let's look at our next case here. We have an inscribed angle, okay, angle BAC. And what's happening here is that point A is moving closer to point C. Now, we know that right here, that this angle is 1/2 of the measure of arc BC. And here it's the same way. It's 1/2 of the measure of arc BC. And even here, it's still intercepting this. It's 1/2 the measure of arc BC. But what happens when point A and point C become the same? Well, nothing happens. Your angle is still intercepting this arc, and the measure of our angle is still 1/2 the measure of arc BC. It should all have arc on them. So even though it is tangent to the circle, remember tangent, it is a line that intercepts the circle in one point exactly, right? That's going to be our next theorem. The measure of the angle formed by a tangent and a chord is half the measure of the intercepted arc. It is still exactly the same. Now, the only thing you have to remember here is here is our chord, here is our tangent line, here is our intercepted, here's our angle, our inscribed angle, but where is the arc? We want the arc that is inside of our angle. Now that one's pretty easy, but what about the next one? Here's our chord, here's our tangent, right? So there is our intercepted arc, or inscribed angle, sorry. There's our inscribed angle, but what arc is it intercepting? Well, it is the arc that is on the interior of our angle. So it's this big arc right there. So you have to be careful, and I'm telling you, use color. Mark your angles, mark your inscribed angles, and then mark your intercepted arcs. So let's look at the next problem. I bet we're going to see how this works. In the diagram, line SR, so let's find line SR, is tangent, so we know that it intercepts at the point of tangency there, is tangent to the circle at point Q. If the measure of arc PMQ, and remember that is going to be a major arc, right, there's PMQ, is 212 degrees, what is the measure of angle PQR. Oh, that's tricky. We want to know the measure of that angle right there. So we are looking at this inscribed angle, right? And where does it intercept our circle? We have a tangent and a chord. We are interested in that arc right there. Well, how are we going to find the measure of that arc? I'm guessing it's the rest of our circle. So 360 minus 212 is 148 degrees. So the measure of our angle, PQR, is half of 148. So that equals 74 degrees. So this is 74 degrees. Now, we could also look at our other inscribed angle here, right? This is the inscribed angle. What is the measure of this angle right here? Well, it's half of 212. What's half of 212? 106. And what do you all see here? Do you see it? Do you see the linear pair? Do you see the 180 degrees right here? 106 plus 74 is 180 degrees. We have a linear pair. That is a line. So again, multiple ways we can do this. Thank you, geometry. And what we are learning now, though, is inscribed angles. These involve a tangent line. All right, pause the video and do the last problem. All right, this one looked a little difficult until you start pulling it apart piece by piece. All right, I'm going to go through it with you in color here. We want to know the measure of x here. And we are told that KJ is tangent to our circle right there. And we are interested in the measure of angle LJK. All right, well, I have a tangent and a chord, so I know that it is going to be 1/2 of the measure of my arc, JL. Well, is there any way to find the measure of arc JL? Well, by golly, yes, there is. I have an inscribed angle right here, angle JQL, and I know that its measure is 35 degrees. I also know that it intercepts arc JL. And so the measure of arc JL is 2 times that, because an intercepted inscribed angle is half of the intercepted arc. So it's 2 times that. So my arc here measures 70 degrees. And I go ahead and I take that 70 and I put it over here. And I can tell you that x is 35 degrees because it is half of the intercepted arc. Now we need to do some more of these. I see a diameter here. There's the center of my circle. So I know that I have a right angle there at J. I know that the measure of angle QJL, it's supposed to be a J, is 90 degrees. And then I can find y simply by triangle angle sum theorem. And y plus 90 plus 35 is 180 degrees. And so y is 55 degrees. So I have found x and y. Y is 55 degrees and x is 35 degrees. Again, these concepts are not difficult. The hardest part is going to be seeing them in the diagrams. Go ahead and redraw pieces as necessary. You know my feeling, color is your friend, and make sure that you label everything that you know. And if you need to draw the picture bigger so that you can see all of your labels and all of your parts, like the measure of x here is kind of difficult to see its chord. Drawing this larger would help. So doing the problems, the math is easy. Seeing them in the diagram is the difficult part. As long as you work carefully, label everything, use your colors, I'm sure you will do fine.